Morning everyone! So for today, we will be discussing the 5 ages of the universe written by Fred Adams and Professor Gregory Laughlin. Now this entails the 5 ages after the Big Bang Theory on what happened or what kind of life existed by these eras. Now they are divided into 5, which is namely the primordial era, the stelliferous era, the degenerate era, the black hole era, and lastly, the dark era. The first age is the primordial era. It is believed to happen t equals 0 or 1 million years after the Big Bang. Now, it is also believed that in this stage or era, subsequent inflation and Big Bang nucleosynthesis happened. And what does Big Bang nucleosynthesis means? Now, this means that it is the production of the nuclei other than the lightest isotopes of hydrogen, which is hydrogen 1, into helium or other isotopes of helium. It is also known as the primordial nucleosynthesis. So in easier terms, it is the combination or the breaking down of protons. Now be minded that this is also the process of creating our elements. Now, if you can recall on our chemistry classes, the atomic number 1, for example, for hydrogen represents its number of protons. Now, if it's 2, it's helium, and so on. Now, it is also believed that in this stage, because of the recombination of the electrons, the universe was believed to be transparent. The second age is the stelliferous era, or what we can call the current age, which happened 1 million years after the Big Bang, or could happen up until 100 trillion years after the Big Bang. Here, matter is arranged in the form of stars, galaxies, galaxy clusters, or planets, with which stars are the most common object in the sky. Stars are also the main source of energy for this era. After the stelliferous era, the degenerate era happens, which will happen for approximately 100 trillion years after the Big Bang, up until 1,000 trillion years after the Big Bang. So imagine how long the span would be from the time as we speak right now. Now in this era, brown dwarfs, white dwarfs, neutrinos, and even black holes are more prominent. Be minded that most of the giant or supergiant stars has consumed all of their fuels and has been converted to dwarfs or white dwarfs, and these dwarfs are more efficient in consuming their energy, thus they are left. In this era also, what's happening is the proton decay. Now this is just a hypothesis because scientists believe that protons, according to the Baron theory, are stable. Now, in this degenerate era, it is hypothesized that it will happen to decay the protons. And what will happen? If the protons decay, it will be converted into its smaller forms, which is the neutral pion and a positron. Now, what does it mean for us? Now, this means that the building blocks of matter will be impossible, wherein life is also impossible for us. So, in this era, it is close to nothing, life exists. The next age would be the black hole era. Now, this happened from 1,000 trillion years after the Big Bang up to 1 Google, which is equivalent to 1,000 trillion, 8 trillion years. So imagine how long that would be. As the name implies, most of the objects we can see in the universe would be black holes. Mainly because all of the stars, even the dwarf stars, have already consumed their energy and no nuclear fusion and nuclear fission is happening due to proton decay. Now, in contrast to what we believe, black holes are not actually black. As they emit energy, they still emit heat and light. Now, in this era also, it is believed that black holes are to disintegrate or will dissolve because of the Hawking's radiation. And what is Hawking's radiation? The last era would be the dark era, which we believe will happen in 1 Google or beyond, or equivalent to 1 trillion years after the Big Bang. In this era, we believe that all particles will be disintegrated to their sub-elementary form, which are photons, electrons, neutrinos, and positrons.
Now, in this era, dark energy is the most prevalent thing that we will be having. Now, remember that dark energy is responsible for the expansion of the universe. And what does that mean? As the universe expands, these sub-elementary particles will not be able to annihilate or even interact with each other. Thus, no energy will be created, which will result to the thermal equilibrium as our universe will meet the absolute zero.